All right. Hello, this is Mr. Crozier. I'm going to go over today's notes again, a little bit slower than we did in class. Problem A, find dy dx. Well, if you have sine of x, it becomes cosine of x, but in this case, it's not x. It's e to the x, so you leave that there, then you always add the derivative there. Number 2, we're going to change this into the 1/2 power, so I always rewrite this as 3x plus 7 to the 1/2 power. Multiply that down and get 3. Subtract 1. Multiply by the derivative of the inside. 9 over square root of 3x plus 7. Next one is x to the 5th becomes 5x to the 4th, and 5 to the x becomes 5x times L on the 5. That's the formula here. There's always 3 parts. There's the original part, the natural log of the base part, and then the derivative of x prime, whatever this is. And the derivative of x prime is just 1 here. Next one, we bring the power down, so that's 5 times pi, x to the 4th, and the derivative of the inside is 16x. Don't forget to simplify that. You need to always simplify what you can. Problem B. Well, I take the derivative. Whoops, I plug in 2 here. If you plug in 2, run it through the equation, you get 16. Take the derivative, that's 5x plus 3. The slope at 2, if I plug that in there, it's 13. And here the tangent at 2, well, there's my equation, and I plug in a 2 and a 16. Now these problems are great if you want to check them on your calculator. You just type them in. Let's see here, we have this typed in, and we're going to take a look at the graph, and it goes up and down. And if I want to draw a tangent, second draw, tangent is 5, and it's asking me for the input, and I want it at 2. So I press enter, and there's the tangent line drawn, and there's the equation down there in the bottom, 13x minus 10. C, the radius of a spherical star is growing at a rate of 85 kilometers per second. How is its surface area growing when the radius is 200,000? Well, right there's the surface area formula. Surface area is 4 pi r squared. If I take the derivative with respect to time, because that's what I want to do, I want to know how they're both changing. Well, this is the, not volume, the surface area. And the surface area is changing by 2 times 4 is 8 pi r to the first now, derivative of dr dt. And so here's how the surface area is changing. 8 times pi times r times dr dt. Well, we have all of these numbers up here. And we have an explicit equation saying this is what ds dt is. It's all of this. Plug everything in there. You have 8 times pi times 200,000 times 85. And that is 4.27 times 10 to the 8th if we put it in scientific notation. On the last one, we're going to graph this equation. Let's go ahead and see what this looks like. Negative 16x squared plus 100x plus 700. The window is 0 to 20 divided by 5s, 0 to 1,000 divided by 250, and there's the graph. The ball goes up, the ball comes down. It's being thrown off a building. In this case is usually the typical story problems. So what's the derivative at 2? Well, math, numerical derivative, x. I'm not going to type this in again. I'm just going to hit y variables and go over to function, whoops, the first function, and I want to know the derivative at 2. There it is, 36. Let's go back to this and watch this. If you draw a tangent at 2, there's that slope. It's going up by 36. So watch this. If I draw a tangent at 7, now the ball's going down, and it's going down 124. I can get that on the home screen just by plugging in a 7 there. All right, now we're asked to find the max. Well, if I go back to graph, let me go ahead and clean this up and start over. The max is somewhere in here, so I hit second calc, and I could, well, one thing I could do is if I have graph, I could just hit trace And I could just go through and then try and estimate where I think the maximum is. And I think the maximum is about right up in here. However, I have to get the exact one. So if you want the exact one, you hit second, calc, go down to maximum, and it's going to ask for a left bound. So I'm going to go way over here on the left of the maximum. Then it asks for a right bound. I'm going to go way over here on the right side. So I know the maximum's in there somewhere. Then it asks for a guess. All right, I'm going to guess that it's right about here, 3.1. What your calculator is going to do is take your guess and find the exact one. So that's the exact one right there, and that's why I put 3.13. And that's the exact height. So the calculator takes your guess and figures out what it is exactly. All right, when does it hit the ground? Well, it hits the ground here. One thing I like to do on the ground problems is I'm going to hit window, and I'm going to go change my minimum to maybe like 250. So now I have a picture of the ball going underneath the ground. It hit the ground. All right, what can I do now? Now I can go to second, calc, and I want the 0 value. So I'm going to go left, I'm going to go right, and right there's the middle. The middle is somewhere in between these two lines when it hits the ground, when there's 0 height. Press enter, and right there at 10.44, there is no height. So that's how you can use your calculator. And if you're ever trying to get numbers off the calculator, it's second, calc, you have it there. We'll use all of these by the end of the year, every single one of those. So make sure you know how to use those buttons. All right, hope this helps with your notes and your test.